All right, welcome. In some of the previous videos, we did some equivalent calculations where we had a matrix and we were calculating the mean value for the entries in each row separately and storing that result to a matrix. And so one way we did that was using an apply function that looked like this over here. So we had a matrix that we called MAT that was a 5 by 2 matrix. And we used the apply function to calculate the mean value of each row. We also wrote a for loop and created a function called myRowMean to do the same thing. And what I want to think about is how does the efficiency of these commands, how do they compare with each other? So clearly the apply function, I think, more is more concise, right? And I think this is more readable code because it's so concise. So that is already one reason to appreciate the apply function. The for loop is a bit more complicated and more difficult to read and less concise. But we also want to consider the efficiency that the code is going to take to run. And we can throw in a third candidate into this comparison, which is there are functions called row means and column means as well. These are built-in functions in R that can do the same calculation. Given a matrix, calculate the mean of each row and store it in a vector. So now we've got three ways of doing that operation. Calculate the mean of each row. We can use row means, we can use apply, and we can use the for loop that we created in the previous question. And one important thing to consider is that the apply function is often more efficient than a loop, but not always. And so it's not true that using an apply function means that our code is vectorized. Actually, these apply functions use loops for the most part, and the output that we get oftentimes is vector, and they work well with vectorization, but the apply functions themselves are loops under the hood, and they're meant for convenience and not necessarily for speed. So we'll compare the speeds here and we can see the results in a moment. So I'm going to use this micro benchmark package that was loaded and installed and loaded earlier to run these code cells. So what this is going to do, it's going to run each of these commands, my row mean, apply, and row means it's going to apply it to the matrix MAT, and it's going to do each of these commands 100 times, and we'll see the distribution of how long it took them to run. So I stored all this output in mean timings, and then we can compare the mean timings with this summary output. So we can see if we're comparing the mean speeds that things took to run, by far that built-in function row means was the most efficient. I think that is probably a vectorized function. It is running really, really quickly. And then our function using the loop was actually faster than using the apply function. It's about twice as fast. And I think that's because the apply function has more capability to work with missing values and return error messages when data is in the wrong type and so on. So that apply function is running some extra loops and conditions to make sure that the data is formatted well, and it can apply this algorithm where we just assumed that the data was nice and just applied that algorithm. But I think otherwise these two processes, the function we came up with, my row means, and the apply function are probably doing things very, very similarly. We can compare speeds and see how things are affected with a larger matrix. So here I'm going to create a matrix called mat2. So this is now going to be a matrix that has, what did I pick here? 100,000 values, and we're going to put it in 10,000 rows. So here we're going to have to apply this mean to 10,000 rows in a matrix. So this is going to take a lot longer, I suspect. And here we're going to compare how our function the loop that we created compares to the apply loop and how that compares to the rowMeans function. And we'll plot the results. Because this is a much larger matrix, this is going to take more time. And there we can see the output. And now the speeds between our loop and the apply function, these are running very, very similarly. The rowMeans function, which again, I suspect is like a vectorized function, that is way more efficient than the loops that we have up here. Okay, so we'll take a look at some additional examples with the apply function in the next video.